Welcome to Maths with AJD. Here we take another structured problem in two parts. The first one is to calculate the coefficient of correlation, that is the Pearson correlation coefficient of the scores in two examinations labeled X and Y given below. XY 20, 23, 25, 20, 32, 32, 55, 43, 60, 59, 75, 70, 83, 84. And in part B, in 200 tosses of a coin, 116 heads and 86 tails were observed. We are to test the hypothesis that the coin is fair using significance level 0.05 and 0.01. So let's move on. Okay. I guess we can just go straight with the Pearson correlation coefficient. So we say A to calculate the Pearson correlation coefficient. That is, I think that's called, is it rho now? I think it's rho. So rho equals n summation xy minus summation x times summation y divided by square root of n summation x squared minus summation x all squared into n summation y squared minus summation y all squared. That's how it's going to be. And then it means we need all these terms so we can get the result. So we have x and y. So for the x and y's, we have 2023 for the first one. Then the next is 2520. Then next, we have 3232. Next, we have 5543. Next, we have 6059. Next is 7570. And next, we have 8384. 8384. And then that's it. I check again, 2023, 2520. I guess I want to do this better. 2520, 32, 32, 55, 43, 60, 59, 75, 70, 83, 84, 83, 84. So with that now, we need, of course, we need summation x, we need summation y. We can easily get summation x here. You can get summation y. Let's start with those. So here, I need, don't forget you need a very good calculator that you are used to, so you don't have to collect someone's calculator and get thrown off balance in the exam. So we need 20 plus 25 plus 32 plus 55 plus 60 plus 60 plus 75 plus 83. Then we'll double check again. 20 plus 25 plus 32 plus 55 plus 60 plus 75 plus 83. That is 350. This is 350, interestingly. Then summation y now, we need that too. That is 23 plus 20 plus 32 plus 43 plus 43, right? Plus 59 plus 70 plus 84. Then I check that again. That's 23 plus 20 plus 32 plus 43 plus 59 plus 70 plus 84. Everything goes to 331. This is 331. So now we've got summation x, summation y that we need. We also need them here and here. So the next thing we need would be, we need summation of x squared and summation of y squared and then summation of xy. So we need x squared, y squared, and xy. So let's go for that. So we have x squared, y squared, and then xy. So we need those. So we can go for them. First of all, we need 20 squared is 400. 20 squared, 20, under tension, don't be too sure of your brain because you can easily get it wrong and think you're right. So 25 squared is 625. 32 squared, 32 is 1024. Then 55 squared is 3025. Then 60 squared, 60, 60 squared is 3600. 75 squared is 5625. 83 squared is 6889. So we go for y again. We need 23 squared. 23 squared is 529. And 20 squared is 400 like before. 32 squared is 1024. Then 55 squared. No, 23, 20, 32. And we need 43 now. 43 squared is 1849. 1849. Then we need, what else? We need 59 squared. 59 squared is 3481. 70 squared is 4900. Then 84 squared is 7056. Okay. Then we have, so we need xy now. So xy is 20 times 23. That is 460. 460. Then we need 25 times 20. 25 times 20. That should just be easy, 500. Then 32 squared. 32 times 32. That's simply 1024. 1024. Then 55 times 43. 55 times 43. That is 2365. 2365. 2365. Then we need 60 times 59. 60 times 59. That is 3540. 3540. Then we need 75 times 70. That's 5250. Then lastly, 83 times 84. 6972. Okay, so now we can do the summing. So let's go for sum of x squared like this. Sum of x squared. What does that give us? 400 plus 625 plus 1024 plus 400 plus 625 plus 1024 plus 3025. 3025 plus 3600. 3600 plus 5625. 5625. 5625 plus 6889. 6889. So 400 plus 625 plus 1024 plus 3025 plus 5625 plus 6889. That's 21188. 21188. Like that. And we need summation of y squared. Summation of y squared. That's again, let's go. 529 plus 400 plus 1024 plus 1849 plus 3481 plus 4900 plus 7056. 7056. So I check that again. 529 plus 400 plus 1024 plus 1849 plus 3481 plus 4900 plus 7056. That is 19239. 19239. And lastly, we have summation of xy, which is now 460 plus 500 plus 1024 plus 2365 plus 3540 plus 5250 plus 6972 6972. So let's check again. 460 plus 500 plus 1024 plus 2365 plus 3540 plus 5250 plus 6972. That is 20,011. I mean 20,111. All right, so we have everything together. So we can say uh therefore rho, which is the correlation coefficient. Again, I just did the formula summation x, y minus summation x, summation y divided by square root of uh, n summation x squared minus summation x all squared into n summation y all squared minus summation y all squared. So we put all the values together. Again, we need to know n, right? N is equal to the pair of values 1, 2, 3, 4, 5, 6, 7, right? 7, yeah, 7. So N is actually 7. So we can put that 7 times summation XY. Summation XY is 2111. 2111 minus summation X summation Y. 350 times 331. 350 times 331 divided by square root of again 7 times summation of x squared. Summation of x squared is 21,188. 21,188. 21,188. Okay, 21,188 minus summation x alone. That's 350 squared. 350 all squared into the other one again. That's 7 times 3. Okay, not 3 anything. Summation y squared is 19239. 19239. 19239 minus summation of y all squared. Summation of y is 331 all squared. So we can go row now. The Pearson correlation coefficient. We have 7 times 2111. That is 140,777 minus 350 times 331. 350 times 331. That is 115,850. 115,850. Okay. Then we have square root of uh again 7 times 21188. 21188. That is 148,316. 148,316 minus 350 squared. 350 raised to power 2. That is 122,500. 122,500 into 7 times 19,239. 7 times 19,239. 7 times 19,239. 19,239. 7 times 19,239 is 134,673. 134,673 minus 331 squared. That's 109,561. 109,561. Okay, so we can begin to tidy things up. Row is at the top, we have 140,777 minus 115,850, 115,850. So 140,777 minus 115,850. That is 24,927. Then down there we have square root of k 148,316 minus 122,500. 148,316 minus 122,500. That is 25,816. 25,816 times 134,673. 134,673. 134,673 minus 109,561. 134,673 minus 109,561. And that is 25,112. So that row is equal to 24,927 divided by square root of 25816 times 25112. 25816 times 25112. That is square root of 6, square root of 648, 648, 648,291,392. 648,291,392. Like this. 648,291,392. And then this is row now. The Pearson correlation coefficient is 24927 divided. So that'll be approximately, we take the square root of this now. Square root of this. So that'll be 25461. 25461.5670. So the Pearson correlation coefficient is approximately 24927 divided by 25461.5670. So that is approximately 0.9, approximately 0.98. Of course, that shows a strong correlation, meaning that as X increases, Y also increases. So that's ends question 1. Question 2, in 200 tosses of a coin, in 200 tosses of a coin, so B now, number of tosses is 200. Then what do we have? We have 186 heads. So total and number of tosses. So number of heads is 116, right? 116 heads and 86 tails. Now something is wrong with that. 116 plus 86 should add to 200, not because 116 plus 86 is 202. So I want to take it that we have 116 heads and 84 tails. So that is number of heads is 116. Number of tails should actually be 86. No, but 84 because it's 200 tosses. So it shouldn't be 86. It should actually be 84. Okay. So the question now is that we have we need to test the hypothesis that the coin is fair using significance level that. So in this case, we have to think about test of proportions. Yeah, I think I mentioned that at some point. if you check the statistics playlist, we have tests of proportions, and that is what we need in this particular situation. Um, so let's see. First of all, we need to do, okay, yeah, we know we want to test, right? We want to test if the coin is fair. If the coin is, we want to test if the coin is fair. That is, if the probability, of heads P exactly 0.5. That's the test we need to do. So first step, right? Step one. So we talk about the hypothesis. Step one, let's talk about the hypothesis. So with the null hypothesis is such that we say the coin is fair, meaning that P, meaning the probability of getting a head or a tail is 0.5. So that way we say the coin is fair. The alternative of that is the opposite. The coin is not fair. The coin is not fair, meaning that the probability of getting a head is not equal to 0.5. Okay. Mm, so the coin is not fair. So once the hypothesis is done like that, let's get a test statistic. Step two, test statistic. Now for test statistic now, but from what we have already, we can compute proportions here. We can say proportion of, uh, we can talk about the proportion of heads. So proportion of heads, that'll be like 116 over 200. And proportion of tails will be 84 over 200. That's still probability in a way, right? So come to that later. Of course, the proportion here, I mean, okay, we'll talk about that as we go as we go on. So here, the test statistic, we have to use the test statistic, for a binomial proportion. Binomial proportion. In that case, Z is P cap minus P naught divided by square root of P naught into 1 minus P naught all over N. Okay. So what are the components now? So P is the observed proportion of its observed proportion of heads. Okay. So observed proportion of heads, right? That will be what I put up there the other time. We had 116 heads, right? So the observed proportion of heads is actually, this implies we have 116 over 200. That's like 58 over 100. That is 0.58. That's 0.58. So that's taken. Then P naught is the hypothesized proportion. So P naught is expected proportion. I think that's better, the idea. Expected proportion of heads. Normally, expected proportion of heads, if the die is fair, should actually be 1 over 2, which is 0.5. So that's that. Then N is the number of trials. N is number of trials, which is 200. Okay. So we have that test statistic. So the next thing is, since we have the test statistic, the next thing we'll go ahead and actually compute the test statistic just the way it is. We need to compute the value, the actual value. Okay, well, I guess we can do that all together here. So we now say therefore Z, which is P cap minus P naught divided by square root of P naught into 1 minus P naught divided by N is actually P cap now. P cap is 0.58, 0.58 minus P naught. P naught is 0.5. So this is P cap here now. This is P cap and this is P naught like this. So that's minus 0.5 divided by square root of P naught, which is 0.5 times 1 minus 0.5. That's simply 0.5, right? All over N. N is 200. This is N. N is 200. So that Z now is equal to 0.58 minus 0.5. That's 0.08, I believe. Yes, 0.08 divided by square root of 0.5 times 0.5 divided by 200. So Z is equal to 0.08 divided by square root of 0.5 times 0.5. That's 0.25 divided by 200. Okay, what can we do here? I think we can compute the numerator directly now. I think we should go for that. Okay, this is 0.25 divided by 200. Okay, I can even still indulge that. So we have Z equals 0.08 divided by square root of 0.00125. Okay, now Z is approximately 0.08 divided by square root of this now. Square root of 0.00125. Okay, square root of this now. That is okay, 0.03, 0.0354. So that Z is approximately 0.08, 0.08 divided by 0.0354. 0.0354. 0.0 divided by 0.0354. You have to be careful. I was almost going to mix that up. 0.08 divided by 0.0354. That is, Z is approximately 2.26, that's approximately 2.2600. So approximately 2.26. Okay. Yeah, approximately 2.26. Now that's the test statistic computed right there. So the next thing is we need a critical value. We need a critical value. So we have step 3, critical value. That's the value you get from the table. Step 3 is critical value. Critical value. So we need to compute that from the table. So another thing is you have to master your table. You need to know your table very well. Don't collect somebody else's table and take it to an example. It's going to throw you off balance. Okay. So let's go. Now we have two critical values here now. Two critical values. So for significance level, for significance level, alpha equals 0.05 now. So if you check your table for that, you get the Z value, to be 1.960. Okay, so we have that. Then for significance level, for significance level, alpha equals 0.01. the Z value, would be something like 2.576. 2.576. Okay, so we have those values now. Let's go ahead to the next step where we make our decisions. So step four is decision. What do we decide based on these things we have seen already? What do we decide? So we can say for alpha equals 0.01, uh, since okay, let's lay it bare, right? For alpha equals 0.01, we already know that Z from the test, right? Z test. We had to do a Z test actually because it's we have a large sample size, 200. So Z test statistic is actually 2.26. That's 2.26. Then Z critical, if you like, that's a critical value. Z critical for alpha equals, oh, sorry, 0.05 now. 0.05. So Z critical for 0.05 is 1.96, 1.960. So what do we decide here? So we say since Z test is greater than Z critical, Z test is greater than Z critical, what do? We reject. We No, we can't reject in this case. If it's less, we reject, but if it is greater, we accept. So for that now, since 2.263 is greater than Z critical, which is 1.96, we reject the null hypothesis. We reject the null hypothesis. We reject the null hypothesis for for alpha equals, for significance value, alpha equals 0.05. Okay, so we reject the null hypothesis and then we accept that the die is unfair. So we can say as such, as such, as such, there is not enough evidence. There's not enough evidence to show that the die is fair. The die is fair for this significance level, right? So we go for the other one. So for alpha equals 0.01, again, Z test is 2.26, like we got 2.26, and then Z critical, that's the table value from the table, is 2.576, 2.576. So now say since Z test is less than Z critical, then we accept or we fail to reject. We fail to reject. That's like accept. We fail to reject the null hypothesis. We fail to reject the null hypothesis. Okay. As such, the die is fair. Okay. The die is fair. And that's how that's going to be. So we reject the null hypothesis for alpha critical level 0.05 and we accept it for critical level 0.01. So you can see that the level of your significance level can determine how the whole thing turns out. So you can see that this test suggests that the 0.05 level at the 0.05 level, there's evidence to reject the hypothesis that the coin is fair. However, at the 0.01 level, there isn't enough evidence to reject the null hypothesis, indicating that the results are not statistically significant at this stricter level. You know, that's how this has been, and we've come to the end of this particular question. I think that's all we are required to do. So practice, practice, and then you get used to some of these things. And don't forget to subscribe to this channel if you haven't done that already. And of course, hit the notification bell so you can always get alerted each time a new video is released. And like, also comment, tell me if you want me to treat a particular topic or solve a particular problem. And share also so that more people can have access to all this great learning. Till I come your way again, keep doing the stats and keep getting the right answers and keep excelling. See you again. Bye.